Welcome back to my channel. So till now I have discussed about the graphs of the functions like algebraic functions and polynomial functions like x cube, x power 2n and x power 2n minus 1, and also the identity function which is y equals to x. From today on I'll be discussing the rational functions. Rational function means it has this property. Let me write it down. So rational function is of the form px by qx, where px is itself a polynomial and qx is itself a polynomial, and moreover this kind of function, this kind of rational function is defined when the denominator, which is qx here, qx is not equals to 0. So this is a rational function. So in this video I'll be discussing about the graph of the function this y equals to 1 by x. Now for plotting the graph of y equals to 1 by x, we can start with the rectangular hyperbola, which is this xy equals to 1 equation. Now what is a rectangular hyperbola? So hyperbola we all know. Suppose we have a hyperbola like this one, and by the rotation of the coordinate axis we get a rectangular hyperbola. So starting from equation like this, x square minus y square equals to a square, we can transform it to an equation like xy equals to c square. So this one here is the rectangular hyperbola. So what we are interested in is this equation here, which is xy equals to 1, the rectangular hyperbola with c square equals to 1. So here we have this plot. Now we can see that from xy equals to 1, we can write it as y equals to 1 by x, our desired graph. Now for understanding the properties of this graph, first we start with the limit at x tends to 0 plus. So what does this 0 plus means? 0 plus means it is very near to 0 but to the right hand side of the 0. So that means if this point here is x equals to 0, or we can write this point as 0 comma 0, then it should be here. It should be here, like very near to x equals to 0, but it is to the positive of x equals to 0. Now here we can see that this property holds, that is for x tends to 0 plus, this limit of this function is positive infinity. So it is apparent from this graph, as the x value goes towards 0 from the positive side, we can see that the y value goes towards positive infinity. Similarly, for the negative side, we can see that as the x value goes near to the 0 minus, which is the left hand side of 0 but very near to 0, we can see that the y value goes towards minus infinity. So here we have these two properties. So okay, so this one should be minus, not plus. This one should be minus. Okay, so after understanding the limits at the left and right hand side of the 0, we can go towards the limit at x tends to plus infinity and the limit at x tends to minus infinity. So from again we can see it from the graph. So for plus infinity here, so for as x tends to plus infinity, we can see that the graph of the function 1 by x goes towards x equals to 0 but from the positive side. okay, not from the negative side. So here we can see, we can write it as 0 plus, as it goes towards the positive 0, the value 0, but it goes through the positive side. So it is 0 plus. So here we have this one 0 plus. Similarly, for the x tends to minus infinity, we can say that this limit goes towards 0 minus. So again, if we go to minus infinity, which is this side, we can see that this curve, this y curve goes towards 0, but it is from the negative side, as it is in the third quadrant. Okay, so these four properties are clear. Now for the domain and range, here we have these two, this and this. So obviously we can see that from this equation alone, x can never be equals to 0, as if x equals to 0, then this function will be undefined. So in this case, x can never be 0, and as x can never be 0, y can never be 0. So that's why the 0 point is excluded from the domain as well as from the range of this function. Now for the other parts, we can see from here that it can take any x value like this, and it can take any x value like this. So positive side of x and negative side of x, there is no problem. Only problem is at x equals to 0. So the domain must be r minus 0. And similarly for the y values, we can see that it can take any values, it can have any value in its range from the positive y side, and similarly for the negative y side too, it can have any value. So only problem is here at 0, 0. So again the range of this function should be r minus 0. Okay. Now y equals to 1 by x is an odd function. So from here we can see that if we take fx equals to 1 by x and we take f of minus x, we get minus 1 by x, and this is obviously equal to minus fx. So obviously this function y equals to 1 by x is an odd function, and for what odd function, we know that it should be symmetrical about the positive quadrant, opposite quadrant. So this is the first quadrant and its opposite quadrant is this third quadrant. So we can see that these two are symmetrical. Okay. Next is if x greater than 0, y is greater than 0, and if x is less than 0, y is less than 0. So here it is obvious, as y equals to 1 by x, and it will be positive if x is positive, and this will be negative if x is negative. So what does it say? It says that, so let me plot the coordinate axis here like this and coordinate axis here like this. So if x is positive, then y also should be positive. That means this side. And if x is negative, y should be negative. So this side. So the graph of this y equals to 1 by x should lie between first quadrant and fourth quadrant, as these two conditions hold. Okay. Next, y equals to 1 by x is a decreasing function. So for decreasing function, we can show that if the derivative of the function is negative, and obviously it is negative, as minus 1 by x square is always negative. So this is negative. So f must always be decreasing. Now if we check the graph of this function, we get that, so here as x increases, the value of y decreases. Okay, in the left hand side of the x equals to 0, and for the right hand side of x equals to 0, again as x increases, so the value of y decreases. Here for this part, it decreases from 0 plus to minus infinity, and for this part what we have, it decreases from 0 plus infinity to 0 plus, and it should be 0 minus actually. 0 0 minus to infinity, minus infinity, and here we have plus infinity to 0 plus, like this. So obviously from the graph it is apparent that this function is a decreasing function. Okay, so next property is that this function has no local extremum, and obviously for local extremum to occur, the derivative, if there is a local extremum at x equals to 0, then the derivative must vanish there. But from here we can see that the derivative is always decreasing and it can never be 0, as f dash x equals to f dash x equals to minus 1 by x square, and it can never be 0. Okay, next is y equals to 1 by x is concave for x less than 0 and convex for x greater than 0. So for finding out the concavity of a function, we need to do the double derivative. So for double derivative, from the single derivative we can see that it is minus 1 by x square. So for the double derivative we have this, so it should be 2 and there should be x cube. Okay, so this is the double derivative. So this will be positive if x is greater than 0, and this will be negative if x is less than 0. Okay, so for the x greater than 0 part, as the double derivative is positive, it should be convex. Convex means it will have this kind of structure, and for x less than 0 we have the double derivative as negative, so it must be concave. So it must have this kind of structure. Okay, and also it is decreasing, so I am taking like this. So if we check the graph of this function, we can see that obviously for x less than 0 part means this part has the concave shape, and for the x greater than 0 part, meaning this part, it has the convex shape. Okay, so for the next property, y equals to 1 by x is continuous in r minus 0. So obviously r minus 0 we are considering here, r minus 0 is the domain, so 1 by x is continuous. So for continuity we can see that if we take any value, suppose a be any value other than 0, okay, so we need to check whether limit x tends to a fx equals to f a or not, and the value of f a is 1 by a. So let me check the limit. So limit x tends to 0, a plus, limit x tends to a plus fx. So here we have limit x tends to a minus fx, and as it is other than 0, so limit should be same. So we have limit x tends to a 1 by x, so it is 1 by a. So these two are equal, so that means this function is continuous in r minus 0. And also from the plot, from the graph of this function, we can see that we can draw it continuously in the interval minus infinity to open 0, and again we can continuously draw it in the interval 0 to positive infinity, open 0 to positive infinity. So it is continuous everywhere except at x equals to 0. As at x equals to 0, the function is not even defined. Next is y equals to 1 by x is differentiable in r minus 0. So let me prove it. So for differentiability, we must have that limit x tends to a, fx minus fa, x minus a should exist. Okay, and here we are taking a not equals to 0 and we are taking fx to be 1 by x. So we have limit x tends to a, 1 by x, 1 by a divided by x minus a. So limit x tends to a minus x, xa, x minus a. So we have limit x tends to a minus 1 by xa. So by putting x equals to a, we get minus 1 by a square. So this function is differentiable at every point r minus 0. And this, as this limit exists, so the derivative also exists. And from the plot of this function, we can see that this function can be drawn smoothly and there are no sharp edges in this function. Now for the last property, here we have the rational function property. So here it is a rational function. So it is an algebraic function. Moreover, it is a rational function. So as I have already mentioned that the rational functions have this kind of structure where fx by gx, where fx is itself a polynomial and gx is itself a polynomial. So here the fx function is 1 and the gx function is x, and gx can never be 0. So gx equals to x not equals to 0 unless it is otherwise defined. So in this video, I have discussed about the graph of the function y equals to 1 by x. In the next video, I will be discussing another rational function which has kind of similar property in the positive quadrant, but the property changes in the second quadrant or the negative side of the x-axis. So thank you for watching this video. Please like and comment on this video and subscribe to my YouTube channel. Thank you.